Hello everyone and welcome to the Redistricting Data Hub's training, how to answer questions about your community. I want to start by first highlighting our website and contact information. Our website is simply our name, redistrictingdatahub.org. Our email is info@redistrictingdatahub.org. And if you need to reach us, you can email us directly, or you can go through our website and find the support button. And there you can submit any questions, suggestions, or feedback, and we'll get back to you within one business day, often sooner. Today we'll be focusing on communities of interest and how you can learn more about them using the data we have on the website. We'll also be doing a quick demonstration at the end of this training. So first, what is a community of interest and how might we go about identifying and measuring it? A community of interest is a mapping criterion that redistricting bodies can include, along with other common criteria such as compactness, contiguity, and others. There is no consensus as to what exactly defines a community of interest. Definitions range from a sentence requiring that map drawers respect them to several paragraphs detailing what does and does not constitute a community of interest. Most definitions generally agree, however, that it is a community, of course, a neighborhood or group of people who share common policy concerns and who could benefit from being drawn into a single district and having a common representative in government. This is a fairly common requirement as half of all states explicitly require consideration of communities of interest for their legislative or congressional maps. Even if your state does not have a constitutional or statutory requirement to consider communities of interest, you can pressure the legislative committees or commission charged with redistricting to adopt it. There's nothing stopping them from adopting that as a requirement. And it has been adopted in the past by some state courts when they have become involved in the process. So given its focus and its prevalence then, communities of interest has a great deal of potential for broad public participation and influence. And it's useful and important to have evidence and justifications for your community. That, of course, can be qualitative, meaning verbal, or quantitative, using our data. If you are submitting maps or testimony, quantitative data can be a compelling part of the evidence in support of your community being kept whole. Given that there are so many different definitions, what are some of the things that you might want to consider when it comes to identifying and mapping out a community of interest? Well, common considerations include existing geographic areas, whether that be a part of a local district or city, or even something that is not mapped out with political boundaries, an ethnic community or religious community, for example. There are often common interests and concerns that you can look at, such as housing, water access, jobs, and these are good reasons why keeping a community intact would result in better representation. Shared community spaces are important, thinking about where does the community get together? What are the places that they value and spend time together in? And lots of other things that I have not identified. Every community is unique, and that means that what defines them will also be unique. So you might be wondering throughout all this, does my state require consideration of communities of interest in redistricting? Or if it does, how do they define a community of interest? And regardless, where and how can I submit a community of interest map to my redistricting body? Well, if you don't know the answer to one or more of those questions, then email us. We can help you, we can direct you to resources and answer many other questions that you might have about the process. So regardless of the answers, local community members tend to be in the best position to define and measure their communities, whether you're using verbal evidence or quantitative evidence or both. This is important to keep in mind as I next introduce some of the data that we have available on the website and highlight what kinds of information you can learn about your community from the data. So again, we are not saying that communities should be defined only by the data we have available. Rather, we see the data as just one more source of information or piece of evidence that can be used to think about communities and what binds them together. There are 4 types of data hosted on our website that are most likely to be useful to someone interested in understanding some basic information about their community. We of course do have other data sets, but these 4 are best suited for an exercise like this one. The American Community Survey data and the Citizen Voting Age Population data both come from the United States Census Bureau. We also have voter file data from vendor L2, which is a national voter file vendor. And we have population projections, which can be used to examine how a community might change over the course of the next decade, provided to us by Haystack DNA. The American Community Survey is done by the Census Bureau separately from the decennial census. It is based on large samples, so the data are estimates. It will contain a margin of error, which is an estimate of how off the actual estimate is likely to be. So if you like polls, especially ones that forecast election results, you'll be very familiar with the concept of margins of error. In contrast, the decennial census data is an enumeration of the population. It's a count of everybody. They're not estimates. They don't have a margin of error. So that's an important difference between those 2 data sets and something to keep in mind when you're using American Community Survey data. In addition, the data that we host are the 5-year estimates, meaning that they include samples, survey samples from 5 years. So the 2019 ACS data includes data from 2015, 2016, 17, 18, and 19. So that also means that on average, the data in the 2019 5-year estimates, for example, are on average about 2.5 years old, meaning on average the data is from 2017. The data include total population estimates and estimates for population by race and ethnicity. And we have these estimates from 2010 up through 2019 for the block, group, census tract, county, and state levels. ACS data is not available at the block level. You have to do disaggregation for that. And so we do not currently host that on the website. These are also offered in both shapefile and CSV format. We will be working with the CSV data sets today. The Citizen Voting Age Population data is derived directly from the American Community Survey. So that means that the same caveats apply here. The data is based on samples, not on enumeration, so they are estimates and they have margins of error. They are on average a couple of years older than you think they are based on the naming convention of the data set. And in this case, the Citizen Voting Age Population, or CVAP data, again contains estimates of the population by race and ethnicity, but only for the voting age population, so citizens who are 18 years of age and older. Like ACS data, they are available for the same years at the same levels of geography and can be exported in the same formats. The voter file data is individual level data that we have aggregated up to the census block level using 2010 census blocks. We do plan to do it at the 2020 level. We're just waiting on L2. This file includes information regarding the count of voters by age group, ethnicity, party affiliation, and election voting history. RDH retrieved the data from L2 and all counts correspond to the voters registered as of March 9th, 2021. We only have the CSV format available for this data set. We also have commercial voter file data with commercial data appended. There is a lot in here, so it is worth exploring. It includes information about language, religion, education, employment and occupation, and much more. Again, like the voter file data, it is available at the 2010 block level, but we plan to have it available at the 2020 level as soon as possible. For the population projections, Haystack DNA used the Census Bureau state level projections and produced block and block group projections. That means they are estimates based on statistical methods and assumptions. So like the ACS and CVAP data, there is some amount of uncertainty here. We have this data for what are known as the P1 and P2 tables. The P1 census table is population estimates by race, and the P2 table is population by race and ethnicity, so breaking it down between Hispanics and non-Hispanics. It is available at the 2010 and 2020 block and block group levels, and it is available for download in both shapefile and CSV format. All of the data sets I just mentioned come with what is called metadata. This metadata explains what each field in the data set contains and also gives you a brief outline of the methodology by which that particular data set was produced. So for example, the metadata for these 4 data sets identify Geo ID as the first field. In fact, let's go look at that very quickly now, because for the demonstration, we're going to be working with data from our website for the state of New York, as well as data from Representable, where I have already drawn a community of interest map in the state of New York where I live. So we are going to be working with the population projections. So there are many ways to sort and filter our data. I'm just going to simply type it into the search bar here. I want population projections based on 2020 census blocks, and I want it at the block group level. So these are the 2 data sets that I am interested in. There's table P1 and table P2. I'll take table P2 that breaks up race by ethnicity. As I said, it's available in shapefile and CSV format, and here's the metadata. So I'm going to click to see the metadata for this particular data set. As you can see, the first field here is the Geo ID, the 12-character 2020 census block group Geo ID. So the Geo ID is the Census Bureau's unique identifier for every level of geography. So every state has a 2-digit code. Texas, for example, is 48, as you can see here. Where I live in New York, the code is 36. And then every county can be identified by the state code plus 3 unique digits. So again, Harris County, Texas can be identified by its state code 48 and its county code 201. For me, I live in Monroe County, which is 055, so my county code would be 36055. And this goes down all the way to the block level. By the time you get to the block level, the Geo ID is 15 digits. Since we're going to be working with block groups, we will have Geo IDs that are 12 digits long. So now we get to the demonstration part, so we can see what can I do with this data to answer questions about my community. So we're going to, as I said, work with data that is available on our website. In this particular demonstration, we're going to work with the population projections. The reason why we're doing that is because the population projections are based on 2020 census blocks. As I mentioned, our voter file data is currently based on 2010 census blocks, but we will be having it based on 2020 census blocks soon. And I want to merge it with a map that I made in Representable. Representable also uses 2020 census blocks. So it's very important when you're doing an exercise like this to make sure that you're using the same underlying geographies. And that applies both to the year of the geographies. So in this case, we're working with 2020 geographies. And it also applies to the unit of geography. So we're going to be working with block groups representable defaults to mapping in block groups, but you can change it to blocks. So when we have the voter file data available, you will also be able to use that. As you can see, Dave's redistricting app also currently uses 2020 census blocks. At the moment, District Builder uses 2010 geographies. So they do plan to update it to 2020 geographies sometime in late August when the legacy format data is released. But that means for the moment, if you are using District Builder, you could also use our ACS and CVAP data to merge with a map made in District Builder. So we've already seen the metadata for our population projection, so I'm going to go ahead and download that data set as well. As always, you have to have logged in, created an account and logged in, which I've already done, and you have to agree to our terms and conditions, which include a prohibition on using the data for gerrymandering. So I'm going to download that data. I'm also logged into Representable. As I mentioned, I live in the state of New York, and I had previously drawn a community of interest map in the area where I live. So I am going to click on that community, and I am going to download a block group equivalency file in CSV format. I am then going to go to my Google Drive. You can do this exercise in Excel or another spreadsheet database. I can confirm that the one piece of code that you're going to have to do for this exercise works exactly in both Google Spreadsheets and Excel. So regardless whether you're using one program or the other, you should be able to do exactly what I am doing here today, and it will work out fine. But as I said, I'm going to work in Google Spreadsheets. So I am going to first upload my 2 files that I have downloaded. So I'm going to upload my representable map, Kate's community. Once it uploads, I am also going to open it with Google Spreadsheets. Then I am going to repeat this process for the population projections that I have downloaded. Once it finishes downloading, I am going to repeat the same process by opening it with Google Spreadsheets. Okay. So I'm going to first do one important piece of cleanup. And that is that I want the name of the column identifying my Geo IDs to match in my 2 data sheets, in the data from our website and the block group equivalency file from my community of interest map. So it's called Geo ID 2020 in this data set. So I am going to also rename the Geo ID in my community of interest block group equivalency file to be Geo ID 2020. This column is irrelevant. We don't actually need it. The other piece of cleanup I am going to do before we actually merge this data and begin to answer questions is I am going to copy this column and I am going to paste it in a new tab in my population projections sheet. It is possible to do this exercise with the data in 2 separate sheets rather than 2 separate tabs in the same sheet. It just makes the that one piece of coding or programming a little more complex. So for simplicity's sake, I'm just going to put it all in one sheet, 2 tabs in one sheet for myself. So let's close that out now that we've got it in our separate tab. So this piece of code that I am going to enter, I'm going to break down here quickly, and then I also will revisit it when we go back to the slides just to make sure that you understand all the components in it. Okay. So I've got my Geo IDs for my community of interest map, In this case, it's pretty small. I only selected 42 block groups for my community. Now I could go through and search for each of those geo IDs here and extract them one by one. But there is something like 14,000 plus, 15,000 plus geo IDs in our population projections. So that would work, but it would be quite onerous. So to save ourselves some time for looking through for these geo IDs one by one, I am going to use some basic coding. I am specifically going to be using what's known as the VLOOKUP. This basically allows Google Spreadsheets or Excel to search for a value and then extract it and place it somewhere else. Okay, so we want to tell Google Spreadsheets to look for these geo IDs that are listed here, and we want to search the other tab for those geo IDs, extract the relevant information, and place it in this tab. Okay, so that at the end we will have all the information that is in these columns here, but only for these 42 geo IDs. Okay, so the first part is that I want to look for the value in cell A1. So I want to look for the value, in this case, geo ID _ 2020. I'm going to next tell it where to look. So I gave it the name of the tab, New York _ BG _ Proj _ P2 _ 2020 tire, which is the name of my tab here. This part tells it where to search within that tab. So the data goes from column A all the way over to column FV. So I want to tell it to look in column A all the way through column FV. Then we want to tell it to to place the first matching value in the column to the left of our current column. Okay. And then lastly, we are going to give it the logical value of false. So either true or false goes here. False means that you will only extract and place exact matches. True allows for approximate matches. I don't think that would occur, but just in case, we want to be very exact and say only exact matches. Okay. So I actually forgot one other important piece here. If you're wondering, why is there an error here? Okay. The one other important step that I neglected to do here, the piece of cleanup, is to delete this first column. Actually want to delete it, not clear it. Okay. So that our geo ID is in column A for both of our tabs. Okay, great. So now my code is working. So I am going to copy this formula. I am going to scroll down to the end of my block group equivalency file, and then also scroll all the way over to the end of my data sheet, and I am simply going to paste the formula. And voila, we have the population projection information for only these 42 block group IDs extracted from this tab and placed here. Cool. So one or two other quick cleaning up formatting things before we actually answer some questions. Just to make it look nice, I am going to clear the formatting so that everything looks the same. That's just a personal preference of mine. It's not necessary. I'm also going to add 2 empty columns up here. You could, of course, sum to the bottom and answer your questions down in the bottom rows here. Just for ease, I'm going to do it at the top. And then lastly, I am going to add a divider, which in Google Spreadsheets you can do by just clicking here and dragging down. And so this allows us to sort of scroll through our block group IDs and our data without losing these headers here. So if you have any questions about what these fields are, that again is what the metadata is for. So we already know that Geo ID is the 12-character 2020 Census Block Group Geo ID. We also know that the P20NH total is the total projected population for this particular census block group. And then it breaks it down by races. This happens to be white, African American, American Indian and Native Alaskan, Asian, and so on and so forth. Okay, so this basically breaks down the block group by race. So if we wanted to know what is the total population in my community of interest, I could simply do sum, and I want to sum C4 all the way through C, I believe it is 45. Let's double check. Yes, 45. Okay. So the total population in my community of interest is almost 51,000 people. I can simply drag this formula across to get population totals for all the other columns, right? So this sums D4 through D45, E4 through E45, so on and so forth, okay? Now, percentages can be often more useful than raw numbers in this regard. So for example, maybe we wanted to know what percent of my total population, my total non-Hispanic population, is white. Well, simply take the percentage. So I would take our non-Hispanic white population and divide it by our non-Hispanic total population, 80%. Now, if I want to replicate this formula across all the columns, I want to keep the total, the denominator, the same, unlike this formula where I was summing and I wanted to update the columns in each case. But in this case, I always want to divide by C3. So I'm just going to add that $sign there before I drag and drop this formula. Okay. And you can always double check and see up here, yes, indeed, here I'm dividing E3 by C3. Here I'm dividing F3 by C3, and so on and so forth. So now you can find out, right, what are the populations for various racial and ethnic groups in my community of interest, and also what do we project that they will be all the way out to 2030 when we will be entering our next redistricting cycle. So there are lots of other possible analyses that you could do here, but those are the basic and probably most common ones that you would be interested in doing, which is generating population totals or population estimate totals, as well as percentages within those groups. So as you all know, the redistricting timeline does differ by state. So one deadline that we are all tied to is the release of the census data, which is scheduled for the end of September. But the Census Bureau has also announced they will be releasing the data in a legacy file format in mid-August. And some of the proprietary software on the market, especially that's being used by most official redistricting bodies, will tabulate the data for you. And that means that those who have the resources will be able to start drawing maps shortly thereafter. So fortunately, we also plan to process and tabulate the legacy format data within a week of its release so that the rest of us can join in. If you're not on the mailing list yet, now would be a great time to join so that you can be notified as soon as we post that data on the website. You can go to redistrictingdatahub.org/newsletter and sign up, or let us know in the chat, or of course, email us at info@redistrictingdatahub.org. And then finally, the survey link is just for us to get a better sense of what organizations would like to see in terms of additional trainings or even suggestions for data sets. It is case sensitive, so please make sure you put the capital RDH and then lowercase feedback. I will also put it in the chat so that you can access it directly there. If you don't have time-sensitive questions or data support inquiries, please send them to info@redistrictingdatahub.org. Otherwise, this concludes our training. So please let me know if you do have any questions, and if I'm unable to answer them, I will certainly pass them along to someone who can and get back to you. Thank you so much for your time today. I really appreciate it. And that is it. Let me stop recording.